Week for Summarization and Descriptive Statistics. Welcome. This week we explore how to make sense of your data using descriptive statistics. We will use the groceries dataset and learn key skills for summarizing real-world datasets. By the end, you will know how to describe, visualize, and get basic insights from complex data. Running the cell now. We begin by hiding warning messages. This makes the notebook less distracting and easier to read. We import the warnings module and use it to ignore all warning messages during execution. Import numpy as np. We set the random C to 42 for reproducibility. Running the cell now. This code sets a random C to ensure that any subsequent random operations produce consistent, reproducible results, an important step when summarizing data or running experiments. Although there's no visible output here, this setup helps maintain reliability as we dive into calculating descriptive statistics on the groceries dataset. We load the groceries dataset. This data contains customer shopping transactions. We import pandas to work with data in tables. We import KaggleHub for downloading datasets and OS for file operations. We download the groceries dataset from Kaggle using KaggleHub. We list the files in the downloaded dataset folder. We find the first CSV file in the folder. We read the CSV file into a pandas data frame for analysis. We print the shape of the data frame to see rows and columns count. We print the first 3 rows to preview the data. Running the cell now. The output shows the dataset has 38,765 rows and 3 columns, member_number, date, and item description. This confirms we are working with transactional data recording which items each member purchased and when. Noticing the dataset size and column type sets the stage for summarizing purchase patterns later in the lesson. Practice, try loading another dataset with pandas for practice. What does the groceries dataset look like? This dataset shows shoppers, dates, and the items they bought. Each row is a single item that a customer purchased on a specific date. For data mining, we want to learn from these shopping patterns. Running the cell now. Let us check basic info about the data. We see column names, data types, and which columns have missing data. This command displays a summary of the data frame including columns, their data types, and non-null counts. Running the cell now. This output shows that our groceries dataset has 38,765 rows and 3 columns, with no missing values, which confirms the data is complete for analysis. Each row represents a single purchase, identified by member number, purchase date, and item description, key details for uncovering shopping patterns. This initial check ensures our dataset is well structured and ready for mining insights. We start by printing a header to indicate we're looking at unique values for items and members. We count and display the number of unique product descriptions in the dataset. We count and display the number of unique customers in the dataset. Running the cell now. Here, we see that the dataset contains 167 unique items and 3,898 unique customers, highlighting the variety of products and the size of the customer base. This helps us understand the dataset scope before diving into mining shopping patterns, ensuring we know how diverse the purchasing behavior is. This line is a comment asking if there are missing values in the data. This line prints the number of missing, null, values in each column of the data frame. Running the cell now. This output shows that there are no missing values in any of the key columns, member_number, date, and item description. This is important because it means our dataset is complete and ready for reliable analysis of shopping patterns without needing to handle missing data first. We ask how many items each customer buys on each shopping trip. We group the data by customer ID to count items bought per trip. We print summary statistics of the basket sizes to understand purchasing patterns. Running the cell now. This output summarizes the number of items each customer buys per trip, showing that on average, shoppers purchase about 10 items, with most baskets ranging between 6 and 13 items. Notice the wide range, from as few as 2 to as many as 36 items, highlighting varied shopping behaviors. This helps us understand typical basket sizes, which is key for analyzing shopping patterns in the dataset. This comment asks what the most popular item is. We count how many times each item appears and keep the top 5. We print the list of the top 5 most purchased items. Running the cell now. Here we see the top 5 most popular items bought by customers, with whole milk leading at 2,502 purchases. This reveals key items frequently bought, helping us focus on common buying habits. Understanding these popular products is essential for mining patterns and making data-driven business decisions. Practice: try listing the 5 least purchased items. What do you notice? We want to find out the total number of shopping trips recorded in the data. We count the number of unique groups formed by each customer on each date. We print out the total count of these unique shopping trips. Running the cell now. Here we see there are 14,963 total shopping trips in the dataset, which means each unique combination of customer and date counts as one transaction. This count is key because our analysis will focus on these transactions to uncover common item combinations, rather than just individual purchases. Understanding this structure helps us prepare for frequent pattern mining in later lessons. Exploring, summarizing with descriptive statistics. Descriptive statistics help us quickly understand the shape of our data. Common summary stats include count, how many; mean, the average; median, the middle value; standard deviation, how spread out the numbers are; minimum and maximum, the smallest and largest values. Let us begin with these basics. Running the cell now. This is a comment describing that we will output summary statistics for basket sizes. This line prints a heading to explain the summary statistics that follow. This line prints detailed statistical measures like count, mean, standard deviation, and quartiles of basket sizes. Running the cell now. This output summarizes the distribution of basket sizes in our dataset, showing key statistics like count, mean, and quartiles. Notice the average basket size is about 10 items, with a spread indicated by the standard deviation of 5.3, and a range from 2 to 36 items, helping us understand typical order sizes and variability in the data. We are asking what day has the highest shopping activity. We count how many purchases were made on each date and find the top 3 busiest days. We display these top 3 busiest dates and their counts. Running the cell now. This output shows the top 3 busiest shopping days by counting how many entries occur on each date. Notice that the highest counts are clustered around 90+ transactions, indicating peak shopping activity on those specific days. This summary helps us quickly identify key dates of interest without scanning the entire dataset, illustrating how descriptive statistics reveal the shape and trends in our data. This comment explains that we are going to visualize the distribution of basket sizes. We import the Matplotlib library to create plots and charts. We set the size of the figure to be 6 inches wide and 3 inches tall. We plot a histogram of basket underscore sizes with bins from 1 to 15, using sky blue bars with black edges. We add a title to the plot to describe what the chart represents. We label the x-axis to indicate it shows the number of items in each basket. We label the y-axis to indicate it shows the number of trips corresponding to each basket size. We adjust the layout so that plot elements don't overlap and everything fits well. We display the plot on screen. Running the cell now. This histogram shows the distribution of basket sizes, how many items customers typically buy per shopping trip. Notice the shape highlights common basket sizes and their frequency, helping us quickly grasp the data's spread and central tendency. This visualization complements descriptive statistics by providing an intuitive, visual summary of the data's shape. Practice: try changing the bins or color to see how the picture changes. We calculate the median number of items each customer buys. We find the median basket size for each customer by grouping their purchases. We print a summary of the median basket sizes across all customers. Running the cell now. This output summarizes the median number of items each customer buys, showing 3,898 customers with a typical median basket size around 9 items. Notice the spread indicates some customers consistently purchase much larger baskets, up to 36 items. This helps us quickly grasp the typical shopping behavior and variability, illustrating how median and quartiles effectively describe the data's shape. Now let us look at shopping habits for one customer. We ask you to type a customer number. Then, we show the 3 items they buy the most. This is great for personalized offers or loyalty programs. Running the cell now. This output shows the top 3 items purchased by a specific customer, identified by their member_number. Notice that each item appears exactly once, indicating this customer bought these items only one time each. This demonstrates how value_counts summarizes the frequency of unique values, helping us quickly understand purchase patterns for individual customers. We create a new summary table. We calculate each customer's average basket size by grouping and averaging basket sizes by member number. We rename the resulting series to average basket size for clarity. We print the first 5 entries of the average basket size table. Running the cell now. This output shows the average basket size per customer, summarizing individual purchase behavior by member_number. Notice how the code groups data by customer and calculates the mean basket size, helping us quickly grasp typical spending patterns across members. This summary statistic is key for understanding overall customer buying trends in a compact form. This comment describes the plot as showing variation in customer basket sizes. Create a figure with a width of 5 inches and height of 3 inches. Plot the average basket size data as a box plot to visualize distribution and outliers. Label the y-axis to indicate it shows average items per basket. Set the plot title to explain the data being shown. Adjust the layout to prevent overlapping plot elements. Display the plot on the screen. Running the cell now. This box plot visually summarizes the variation in average basket sizes across customers, highlighting the median, spread, and potential outliers in the data. Notice the range and interquartile spread, which give a quick sense of typical and extreme basket sizes. This helps us understand customer purchasing behavior more intuitively, complementing numeric summary statistics. This comment explains that we are going to calculate the median, minimum, and maximum basket size for each customer. Here, we group the basket sizes by each customer's member number and calculate the median, minimum, and maximum number of items they buy. This line prints out the first few rows of the resulting basket statistics to check the summary values for some customers. Running the cell now. This output shows the median, minimum, and maximum basket sizes for each customer, helping us understand individual shopping patterns. Notice the consistent values across median, minute, and max columns here, indicating each customer has a single basket size recorded. This confirms the code's role in summarizing data distribution by customer, a key step in descriptive statistics. We are identifying which customers purchase the largest baskets on average. We sort the average basket sizes in descending order and select the top 3 customers. We print out the top 3 customers who buy the most items per visit. Running the cell now. Here, the code identifies the top 3 customers with the largest average basket sizes, showing their member numbers alongside their average quantities. Notice how the largest basket size is 36, followed closely by 2 customers with 33 items each, highlighting key outliers in purchase behavior. This summary helps us quickly pinpoint which customers contribute most to sales volume, a crucial insight in descriptive statistics for understanding data distribution. Wrap up and what next? You have learned to use descriptive statistics and summaries to learn from data. You practiced with the groceries dataset and saw how simple stats can reveal powerful insights. Try more questions. Can you find customers who rarely visit? Discover which items are bought together? Spot shopping habits during holidays? Next week, association rules and market basket analysis. Like and subscribe for more data mining tutorials. Running the cell now. Challenge, practice and share. Try answering, who are the most loyal customers? Can you make a new chart or summary with Matplotlib or Pandas? Share your code in the comments. We love to see your progress. See you in the next lesson. Running the cell now. Practice, pause now and pick a question to try for yourself. Good luck!